Question 2a, the line 3x minus 6y plus 2 equals 0 contains this point where k is an element of the real numbers. Find the value of k. So we're kind of linking this here where it says contains the point. So if a point is on a line or on any curve, we know when we sub it in, it should satisfy it, or it should equal to 0. So all I'm going to do here is basically sub in my point, k for x, and 2k plus 2 over 3 for my y. So I'm subbing it in, and I should get equal to 0 when I solve it. So let's go with that. So 3 times my k, which is my x value, minus 6 times y, and my y in this case is 2k plus 2 over 3. And I'm going to then add my plus 2 and let that equal to 0. So I'm going to solve this now. So multiplying in 3 into the k gives me 3k. And then multiplying in this fraction. So think of the 6 as being over 1. And when I multiply fractions, it's top by top, bottom by bottom. So if I multiply the top, I'm going to get 6 times my 2k is minus 12k. And minus 6 times positive 2 gives me minus 12. So just watch the minus there. And on the bottom, when I multiply it in, I get 1 times 3, which is 3. Now the minus there with that 6 either goes to the top or the bottom of the fraction, but not both. So just watch out for that. And then I add on my plus 2 equals to 0. And now I'm basically going to, well actually I can divide that 3. That 3 will divide into the 12. 4 times, so I have 3k minus 4k, and the 3 will divide into this minus 12 minus 4 times. Okay, so that's making it a bit easier for me. And then I put in my plus 2 again, so plus 2 is equal to 0. Then I group them. Minus 4k plus 3k is minus 1k. Minus 4 plus 2 is minus 2 is equal to 0. If I add 2 to both sides or move over to minus 2, I get minus 1k is equal to positive 2. So dividing both sides by minus 1, I get k is equal to negative 2. Okay, so that's not too bad. Part B, the point P is on the line. The point P is also a distance of 1 unit from the line 4x plus 3y plus 6 is equal to 0. Find a value of s and the corresponding value of t. So let's see what this would look like if I was to sketch it. So I have a point P on this line x minus 2y minus 8 equals 0. And P is on that line. The point P is also a distance of 1 unit from another line. And I'm going to just sketch that other line in grey here. And it's 1 unit away from it. And I'm going to take that as the shortest distance. So the shortest distance would make 90 degrees there. And it's 1 unit away from the line 4x plus 3y plus 6 is equal to 0. Now what they're telling me is that the point P, which is this line, this point here in red, is ST. Now once again, it's similar to part A. If that point is on the line x minus 2y minus 8 equals 0, I'm going to satisfy that by subbing in s and t for x and y. So that's the first thing I'm going to do, just to verify the point sits on the line. So I'm taking the line x minus 2y minus 8 is equal to 0, and the point P, which is ST, is on the line. So I'm basically going to sub s in for x and t in for y. So that's giving me s minus 2t minus 8 is equal to 0. Now that's the same as going s is equal to positive 2t plus 8. And we will need that in a second, I think, if we're going to get the distance now to the other line. So let's think about this. So the grey line, 4x plus 3y plus 6 is equal to 0, is 1 unit away from the point ST. Now, on my picture, remember that we marked these in as 90-degree angles. So the shortest distance from a point to a line is by using the perpendicular distance. And that's our formula from our log tables, which is the perpendicular distance formula, which is written as ax1 plus by1 plus c, and then the modulus brackets, all over a squared plus b squared. And that'll give me the shortest distance. And if I sub in my information, my a is the coefficient of the x, the b is the positive 3, and the c is the constant, which is the plus 6. And x1 is the s, and my y1 is my t. So I'm basically subbing them into the formula now. So it's going to give me, so let's just draw our brackets here. It's always good to use brackets, particularly when there's negative signs, but I think we're okay in this case, but let's do it anyway. All over the square root of a squared plus b squared. So filling it in, my a is 4, my x1 is s, my b is 3, and my y1 is t. And then I'm going to go plus my c, which is 6, all over 4 squared plus 3 squared. And when I multiply that out, I get 4s plus 3t plus 6 in my modulus bracket, all over the square root of 25, which is 5. Now don't forget, this is equal to my distance, my shortest distance, but they tell me in the question that the distance is 1 unit. So I'm letting this equal to 1. And what I'm then going to do is I'm going to put that 1 over 1, make it a fraction. So if a fraction equals to a fraction, quick way of doing fractions equal to fractions is when they're equal, instead of going off and getting my common denominator is 5. So if I cross multiply, let's just move it up here, I get the modulus of 4s plus 3t plus 6 is equal to 5 times 1, which is equal to 5. And what I'm now going to do is, because I have it in terms of two variables, s and t, I'm actually going to take this piece of information I have over here. Remember we said that s is equal to 2t plus 8. So I'm actually going to take that and sub it in here for my s. So that's my next step. So I'm going to say let s is equal to 2t plus 8. And when I sub that in, I get 4 times 2t plus 8 plus 3t, and now I basically have it in terms of one variable, which makes it a lot easier to solve. So I have, what does that solve out as? 8t, 4 8s are 32, add that 6 gives me 38, plus the 3t equals 5, which is giving me 11t plus 38 is equal to 5. Now we're basically going to come to these brackets, these modulus brackets. Remember what they mean. They mean that we turn our answer to positive. So this question could be, so we have two solutions, 11t plus 38 is equal to 5, or it could have given me a negative 5, 11t plus 38 is equal to negative 5. So it could be positive or negative. And when we solve that, again here I'm going to subtract 38 from both sides, will give me 11t is equal to 5 minus 38, which is minus 33, is equal to 11t. So t is equal to minus 33 divided by 11, both sides by 11, gives me t is equal to minus 3. Now I can have two values, so on the other side, I can also subtract 38 from both sides here, which would give me 11t is equal to minus 5 minus 38, which is 11t is equal to minus 43. So that gives me t is equal to minus 43 over 11 when I divide both sides by 11. So we've found t, but the question says find a value of s and the corresponding value for t. Now I'm doing it out twice here. You can see I'm finding both values for t, but they only asked for a value for s and its corresponding t. But look, I'm going to do both. So we now have to find the corresponding s. So let's see. So now find s. So when I come back to my s, we know that s is equal to 2t plus 8, and I'm going to sub in my value for t, which in this case is minus 3, and that's giving me a value for s, which is minus 9 plus 8, which is giving me s as equal to minus 1. So my value for s and t in this case are, so therefore s is equal to minus 1 and t is equal to minus 3. Sorry, I've made a mistake there on that. That should be a 2, shouldn't it? What am I doing? So that's a 2. which gives me minus 6 plus 8, and minus 6 plus 8 is 2. So my S there is positive 2. Sorry, my fault on that one. So S is 2, T as minus 3. And coming over to the second possible solution, so we'll say now find S. So I have S is equal to 2T plus 8, which would be 2 times minus 43 over 11 plus 8. And when I put that into my calculator, I get S is equal to 2 over 11. So therefore, I could have S is equal to 2 over 11 and T is equal to minus 43 over 11. Okay, so that's part B done. We're now going to have a look at the final part to it, part C. The point A and C are vertices, so corners, of the triangle ABC as shown. D and D are points on CA and CB respectively. The ratio AD is to DC is 2:1. So they want us to find the distance from A to D. So they want us to get the length of this line here. Well, basically what I'm going to do is, I'm going to get the distance from A to C first of all. And then I'm going to use the ratio here to split that length AC in the ratio of 2:1, which will get me then the distance from A to D, because it is in the ratio 2:1. So using my log tables, my distance formula is given as x2 minus x1 all to be squared plus y2 minus y1 all to be squared, and that's in our square root. So that's coming from my log tables. And the distance I'm getting is between A, which is 4,2, and C, which is 16,11. And labeling those 2 points, x1, y1, x2, y2, and subbing them into my distance formula now. So distance between A and C is x2, which is 16, minus x1, which is 4, squaring that, plus y2 minus y1, squaring that, and then getting the square root of that value. So my distance from A to C, so let's now call it A to C, is 12 squared plus 9 squared, which is giving me, what's that giving me? 144, isn't it? Plus 81, all to be square rooted. Bringing that up then gives me a distance from A to C as square root of 225, which is 15. So the distance from A to C is 15 units. Now it's split then in the ratio of 2:1, and to get the ratio then you add the ratio, so 2 plus 1 is 3, and basically then A to D is going to be 2/3 the length of the line AC. So it's 2/3 of AC. So basically I'm just taking 15 dividing by 3 multiplying by 2, or 15 multiplied by 2 over 3, which is 10 units in length. Now you could also use your ratio formula from your log tables, but I think using the distance formula is a little bit easier. Coming down now to part 2 of part C. So AB and DE are horizontal line segments. AB is 33 units in length. Find the coordinates of B and E. So what I'm going to do here is I'm going to use knowledge of similar triangles here. So let's sketch out what we know. So we have the smaller triangle C, D, E. So that's the smaller triangle, and let's fill in what we know. 16, 11 is the coordinate. We then have the larger triangle, the full triangle. Again, these aren't to scale, but it's just to kind of visualize it. And I have the C coordinate as 16, 11 at the top again. And I have A, bottom left vertex A as 4, 2, and the other vertex B. And that's what I actually need to find. I need to find B, don't we? So let's start with B, as I say. I'll come to E then in a couple of minutes. So let's fill in some information onto our diagram. We know the distance from A to B is 33 units. So that's given in the question. We also know from part 1 up above that the distance from A to C is 15 units. So we're going to write that in. And we also know that the distance from A to D would be about here, is 10 units. Now again, this isn't to scale. So that means the distance from D to C is 5 units. I'm going to write that on my smaller triangle. So let's kind of use a little bit of basic knowledge here. Using similar triangles, how have I gone from 15 to the 5? So in order to get from 15 to 5, I'm dividing by 3. So if I want to go from 33 to this length, it means I have to divide 33 by 3, which gives me a length of 11 units. So that's a little bit of information that we know. So let's see, can we figure out anything else here now? The coordinates of A are 4, 2. Now this is a horizontal line, so that means then that the y coordinate there does not change. So in my coordinate B, my x must be 2. Because it's a horizontal line, think of it, it's just sliding across from left to right. But now we have to find the x part. In A, it's 4, 2. But basically what's happening here is I'm going 33 units along that horizontal line. So to get the value of the x, I'm at 4 when I'm at A, and I need to add on 33, which brings me to 37. So the coordinate B is actually going to be 37, 2. So that's finding the coordinate of B, just by using a bit of simple mathematics, playing around with the similar triangles. Let's have a look now at finding the coordinate E. So what I'm first of all going to do is I'm going to sketch out the diagram from up above so we can mark in on it. Okay, so it just makes it a little bit easier rather than scrolling up and down. And what else do we know on the picture there? We know that B is 37, 2. Is something else we know. Okay, that's about it. So let's have a look at it here. So we're trying to find the coordinates of E now. And if you think about this here, if we focus in on the y coordinate here, if we want to find y, if we focus in on the y of the C and on the B as well. So remember that this is like in xy axis. This is a coordinate graph basically. So we're basically getting the distance from here at the top of C all the way down to this line here, AB. So that distance there is between 11 units high on the x-axis and 2 units high. So basically what I'm doing there is, if I take 11 minus 2, I get 9 units. So basically what that's telling me is that the distance from AB to the vertex C, if I was to go perpendicular height, would be 9 units in height. Now, again, the ratio here is, it's split in the ratio 2 is to 1, which is giving me 2 plus 1 is 3. So basically, the distance from E to C will be 1/3 the length of that 9 units. So if I get 1/3 of 9 units, I'm getting 3 units. So basically all I want to do is, I basically want to start at C and go back 1/3 the length of that line, which is 3 units in other words. So I'm going back 3 units. So if I go 11 subtract 3, so therefore 11 subtract 3 will give me 8 as my y. So my E is starting off as xy, so x8 in other words. So that's the y coordinate found. Now I need to find the x, and I'm going to tackle it in the same approach. What I'm going to do here now is, if we look on the horizontal axis, so I'm going from, let's say I'm going from C. So again, let's draw a line down. So I'm going from here all the way to B. So there are two distances that I know. So what's the distance there going to be? Well, the x is 16 minus from the 37. Actually, let's go the other way. So 37 subtract the 16, which is giving me 21. So the distance from C to B on the horizontal is going to be 21 units. Now it's the same again. I'm looking at 1/3 of that. So let's write that over here actually in the box. Kind of stuck for space here in this. Now there's different ways you could do this. This is just the way I'm spotting it through, a little bit of problem solving here. So that's 21 units. And I want to find 1/3 of that. So 21 multiplied by 1/3 is equal to 7 units. Now what do I want to do with the 7 units? Think about this now. What way are we going? So I'm starting at 16 and I want to come over 7 units because it's going in the positive direction. So I need to add on 7 to 16. So therefore 16 plus 7 is bringing me up to 23. So my y is going to be 23. So filling all that information in now, I have B as 37.2 and I have my E as, I've lost it now, 23.8.